Number 8, Mr. Jones needs to get a loan to replace the air conditioning system in his home. The cost of the replacement installation is, including installation, is $3,672. He can apply for a 6-year loan or a 4-year loan. Both involve simple interest, so we know we're doing the P times R times T, with an annual rate of 8.5%, and 8.5 divided by 100 is 0.085, so that's the number we'll use. If he applies for the 6-year loan, how much more will he pay? So we're going to be subtracting again than with the 4-year. So I'm going to fill this in. Okay, so when I type the first one in the calculator, I plugged it in, the PRT. I get 1872.72. And when I do the second one with the 4 years instead, I get 1248.48. So I want to subtract these two. So 1872.72 minus 1248.48, and I get 624.24. Number 9, Morgan's mother started a college fund on Morgan's 11th birthday. This is important. She deposited $9,800 to your principal into a CD that yields an interest rate of 0.36%. I'm going to go ahead and divide that by 100 so I don't get confused. So 0.0036. And then it says compounded annually. I'm going to focus on the word compound, and that tells me I'm going to be using the compound interest formula. How much money will the CD be worth when Morgan turns 18 years old? So they didn't technically give me a year. A lot of kids want to put 18 because that makes the most sense, but she didn't start the fund until she was 11. So we need to see how many years have passed between her 11th birthday and her 18th birthday. So we want to subtract 18 minus 11, and that would be 7. So my time is actually 7 years, because that's how long she's had the money deposited. Or she's wanting to see, whatever. Okay, so I'm going to plug my numbers into this formula. P parentheses 1 plus R exponent T. So 9,800 open parentheses 1 plus 0.0036 close parentheses and 7. So 9,800 open parentheses 1 plus 0.0036. And then 7 up as your exponent, and I get 100,049, which would be 10,049. D. 10 over 3 years. How much more, here we go again, we're going to subtract, will a savings account with a simple interest rate of 9.3% yield and earnings than a savings account with a simple interest rate of 3.2% if the original balance is $19.50. So we want to do simple interest with 2 different percentage rates, and it says how much more, so we're going to subtract. So I'm going to do the same formula for both. I'm going to plug those in. Okay, and the years was 3, so I did 1950 times 0.039 times 3, and then 1950 times 0.032 times 3. And for the first one, the 39, I got 228.15, and the second one, I got 187.2. And so when I subtract those, I get 40.95, which would be B. Number 11, Billy Bob is going to apply for an $18,000 loan. He's considering offers from 3 different banks. So there's a 3-year loan with 6.5% interest rate compounded, 7-year with 4.9% interest rate compounded, and a 10-year with the rate compounded. So I'm going to write the formula down 3 times. And I'm going to fill those in. So I'm going to start with the first interest rate. So I've got 18,000, 1 plus 0.019 It's a 0, 6, 5, and the time is 3. And then I'm going to do this one, 18,000. 1 plus the rate would be 0.049. And the time on that one on bank B was 7. And then the last one, my principal amount, 1 plus 0.0375. And that was a 10-year loan on bank C. Okay, I'm going to plug these all in the calculator and get my totals. Okay, so these are my totals for each. So this is bank A, B, and C. And the answer choices are all saying the most or the least of interest. So just to solve what the interest is, I honestly think we could go off of these numbers. But just to be sure, I'm going to subtract the principal amount from each of these totals because we want to, the answer choices are comparing just the interest. So I'm going to subtract the starting amount to get my interest. Okay, so here are my interests for each bank. That's just what the interest is. So let's look at the answer choices. Billy Bob will pay the most interest if he chooses bank A. So when I look at bank A, it's 3,000. Bank B is 7 and bank C is 8. So that would not be the most interest. That's actually the smallest number. B, Billy Bob will pay the least amount of interest in bank C. And we've already decided that that wasn't right because that's actually our largest. C, Billy Bob will pay the most interest if he chooses bank C's offer. That's so far pretty true. Billy Bob will pay the least amount of interest if he chooses bank B. B was in the middle. We had 3, 7, and 8. So like I said, you could have gone off of this original number, but just to be sure on that, I double checked it since it was asking about interest. Okay, on number 12, Chelsea is a chemist working with liquids and solutions. Remember when we're doing this, we want to focus on the keywords and the numbers. So you don't have to read every single word. But I see this, and I'm not sure if I'm going to need that or not. So we're comparing two things. I've got the first barrel contains 1,400 liters of solution, and the second barrel. So I've got 2 barrels I'm comparing, and the second one contains 500 liters of solutions. So I'm going to, because it's going to jump around, it'll talk about the first and then it'll talk about the second. So I'm going to separate them out and write everything I know down here. So in the first barrel, she had 1,400 liters. The second one had 500. She began draining the first barrel at a rate of 54 liters per minute. So I'm going to put 54, and that's per minute, so that has the variable on it. And then Chelsea fills the second barrel with 58 liters of solution every minute. So here's the only difference, draining and filling. So if we're draining something, we're getting rid of something, that would be subtracting. And if we're filling something up or adding to it, that would be addition or a positive. So first thing I want to do is make sure that my numbers match up so that 1,454 are together. So A has 1,454 together, B has not what we need, C has 54 and 1,400 together, and D has 54 and 500 together. So that's not what we want. Okay, next thing I want to look at is, are they... we want to look at the question. I'm so sorry. Which inequality represents S the seconds when the second barrel contains a greater or equal? So I'm going to write that down. So we want the second barrel to be greater or equal than the first. So the alligator mouth needs to be open up to the side that has 558. So 558, I see that right here, 558. And this 54 is a negative, which is what we wrote down also because it was draining. So number 13, Katie deposited 3,502 to her account. So we actually don't need that number. She deposited $1,500 into an account that pays 6.5% simple interest, so that's the PRT. She deposited $2,000 into an account that pays 5% compounded, so that's a different formula. So we're going to actually be doing both on this one. She does not deposit additional money into the accounts, and she doesn't withdraw any money from the accounts, which is the closest to the total balance she will have in the two accounts at the end of 6 years. Okay, so I'm going to write my two formulas down because I'm going to need both of them. I don't want to lose them. And then I'm going to write down the first one that goes with the simple interest. So my principal amount is $1,500 times the rate divided by 100, so that would be 0.065, times the years, which is the same for both. So in the question it says which is the closest to the total balance we will have in the two accounts. So we want to find the total balance for each and then add them together. So when we do simple interest, when I use this formula, I'm just finding the interest. So when I multiply 1,500 times 0.065 times 6, I get 585. That's not the total amount in her account because your total amount can't be less than what was already in there. Okay, so this is just the interest. So I'm going to add that to the starting amount. We're going to see how much we have total. 2085. Okay, this is an important number I'm going to need. I'm going to circle it. Now I'm going to do the second account with the compound interest. So 2,000, open parentheses, 1 plus the rate, which was 0.05, because I divided it by 100, and then 6. So when I do this formula in the calculator, I'm actually getting the total already. So when I do all of that, I get 2680.19. Okay, so that already is the total. I don't have to add, I don't have to do anything. And it wanted the balance of the two. So we're just going to add those numbers together. And when I do that, I get 4765.19. And the last one, which problem situation cannot be represented by this equation? So we want one that does not work. So on A, Brian has a barrel that begins with 3/4 liquid, which 3/4 would be the same as 0.75, and fills the barrel with more liquid at a rate of 2 every 5 minutes. So that would look like this, which, so far that works. Ava has a barrel that begins with 4, okay, and fills the barrel with 3 more liters of liquid every 10 minutes. So that would look like this, and if we divide that, we get this, which is perfect. So that actually works, which means that can't be our answer because that worked. So B, David has been given a small tree. The tree is 4 feet tall. Okay, so we have 4, and grows 2 feet every 5 years, which would look like this, which is on the opposite side, which means this one is going to be our answer because we were looking for one that was wrong.